is Javin Kharod, a production chemical engineer by profession, going to continue our today's topic, pump operations. Now, centrifugal pump. A centrifugal pump is a rotodynamic pump that uses rotating impeller to increase the pressure and flow rate of a fluid. Centrifugal pump are the most common type of pump used to move liquid through piping system. The fluid enter the pump impeller along or nearer to rotating axis and is accelerated by impeller following radially outward or axially into diffuser or volute chamber from where it exits into downstream piping system. The centrifugal pump are typically used for large discharge through smaller head. Centrifugal pump are most often associated with radial flow type. However, term centrifugal pump can be used to describe all impeller type thermodynamic, rotodynamic pump, including radial, axial, and mixed flow variations. Now, radial flow pump. The often simply refer the centrifugal pump. The fluid enter along with axial plan. It is accelerated by the impeller and exit right angle the shaft radially. Radial flow pump operate higher pressure and lower flow rate than axial and mixed flow pump. Axial flow pump. The axial flow pump different from radial flow in that fluid enter and exit along same direction, parallel rotating shaft. The fluid is not accelerated but instead lifted by the action of impeller. There may be propeller, spiny, a length of tube. Axial flow pump operate at much lower pressure and higher flow rate than radial flow pump, mixed flow pump. Now, what is mixed flow pump? Mixed flow pump, as the name suggests, the function is comprised between a radial and axial flow pump. The fluid experience both the radial acceleration and lift and exit the impeller somewhere between 0 to 90 degree from a axial direction. As a consequence, mixed flow pump operate a higher pressure than axial flow pump while delivering higher discharge than radial flow pump. The exit angle, the flow dictate the pressure head discharge characteristic in relation to radial and mixed flow. Ejector jet pump. Now, this causes a jet of steam to create a low pressure. This flow pressure stuck fluid to propel it into a higher pressure region. Gravity pump. A gravity pump includes the siphon and harmon, fountain, and there are also imported general or flora system which simply use downhill flow to take water from far underground aquifer in higher area to consumer lower elevation. The hydraulic ram is also sometimes referred a gravity pump. Now, steam pump. Steam pump are now mainly historical interest. They include any type of pump power, the steam engine, and also pistonless pump, such the survey pump and the pulsometer steam pump. The valveless pump. The valveless pumping assist the fluid transport, various the biomedical and engineering system in a valveless piping system. No valve are present. Regulate the flow direction. The fluid pumping efficiency valveless system, however, not necessarily lower than having valve. In fact, many fluid the dimensional system, nature and engineering more or less really upon valveless pumping to transport the working fluid, therefore instant blood circulation in cardiovascular system to maintain some extent even the heart valve full. Meanwhile, the embryonic portable heart being pumping blood long before the development, discrete chamber and valve and microfluid valveless important pump have been fabricated and more expected to a particular suitable for handling sensitive biofilm. Now, move further. Its applications. Pump are used throughout society for a variety purpose. Early applications include the use windmill, watermill pump, water. Today pump is used irrigation, water supply, gasoline supply, air conditioning system, refrigeration, chemical movement, sewage movement, flood control, margin service, etc. Because of the wide variety application, pump have the shape and size from very large to very small, from handling gas to handling liquid, from higher pressure to low pressure, and from high volume to low volume. Now priming pump. Liquid and slurry pump can lose prime and this will require pump to be primed, adding liquid to the pump and inlet pipe to get the pump started. Loss of prime is usually due to ingestion the air into the pump, clearance and displacement ratio in pump use to liquid and other more viscous fluid can be displaced the air due to its lower than cities. Now, its multiple applications. Multi-phase pumping application, also referred the tri-phase, have grown due to increased oil drilling activity. In addition, the economic multi-phase production is attractive upstream operation and is lead to simpler, smaller in-field installation, reduces equipment cost and improve production rate. In essence, the multi-phase pump can be accommodated all fluid stream property with one piece equipment which has a smaller footprint. Often, two smaller multi-phase pumps are installed in series rather than having just one massive pump for midstream and upstream operations. Multi-phase pump can be located onshore, offshore, and can be connected the single or multiple wellhead. Basically, multi-phase pump are used to transport the untreated low stream produce with oil well and downstream process the gathering facility. This means the pump may be handled a flow stream from 100% gas to 100% liquid and every imaginable combination in between the flow stream can also contain abrasive such as sand and dirt. Multi-phase pump designed to operate under changing fluctuate process conditions. Multi-phase pumping help eliminate emission of greenhouse gases as operate strive to minimize flaring of gas and venting a tank where possible. Now type future of multi-phase pump. Pump utilize open type axial impeller. The pump type is often referred to Poisson-Eck pump and can be described to crosses between the axial compressor and centrifugal pump. Twin screw positive displacement pump. The twin screw pump is constructed to intersmashing screw that forces the movement of pump fluid. The twin screw pump are often used. The pumping condition contain high gas volume fraction and fluctuate inlet condition. The four mechanical seals are required to seal the two shaft progressive cavity pump. The progressive cavity pump are single screw type typically used shallow well and the surface and the pump is mainly used on surface application where the pump fluid may contain considerable amount the solid such sand and dirt. Electric submersible pump. The pump basically multi-stage centrifugal pump and widely used the oil well application in method or artificial lift. The pump can usually specify when the pump fluid is mainly liquid. A buffer tank. A buffer tank is often installed upstream of the pump suction nozzle. In case sludge flow, the butter tank breaks the energy of the liquid sludge, smooth fluctuation in incoming flow and act as a sand trap. As the name indicates, multi-phase pump and their mechanical seat can encounter large variation in service conditions such as changing process, fluid composition, temperature variation, high and low operating pressure, and exposure to abrasive erosive media. And the challenge is selecting appropriate mechanical seal arrangement and support system to ensure maximize seal life and overall effectiveness. Now specification. The pump are commonly rated horsepower, flow rate, outlet pressure in feet, head, inlet suction, in suction feet of head. The head can be simplified. The number of feet meter the pump can rise or lower column, water, atmospheric pressure. From initial design point of view, engineer often use quantity term, the specified speed, the identify the most suitable pump type, particular combination of low rate and head. Pump material. Pump material can be stainless steel, SS316 or SS304, cast iron. It depends on application of pump. In water industry, the pharma application SS316 is normally used and as high temperature stainless steel give better result. Pumping power. Now, what is that? The power imparted into a fluid will increase the energy of a fluid per unit volume. Thus, the power relationship in between conversion, the mechanical energy of the pump mechanism and fluid element with the pump is general. This is governed the series of simultaneous different equations known as Navier-Stokes equation. However, more simple equation relating only different engine in the fluid known Bernoulli's equation. Hence, the power required by the pump delta P is the change in total pressure between inlet and outlet. The Q is flow rate given in meter cube per second. The total pressure may have gravitational, static pressure and kinetic energy component. Example, distributed between change in fluid, gravitational, potential energy, change in static pressure, N is pump efficiency and be given manufacturer information, the form of pump curve and typically derive either fluid dynamics simulation, Navier-Stokes, particular pump geometry. By testing the efficiency pump will depend upon pump configuration and operating condition such rotational speed, fluid density, viscosity. From typical pumping configuration, the work is imparted on fluid. This is positive for a fluid imparting. The work on the pump work is negative power required to drive the pump determined by dividing the output power by the pump efficiency. Furthermore, the definition encompasses the pump with no moving part such as siphon. Now, it is pump efficiency. The pump efficiency is the defined ratio of power imparted fluid by the pump in relation to the power supply to drive the pump. The value is not fixed. The given pump efficiency of function, the discharge and therefore also operating head, the centrifugal pump, the efficiency tend to increase with flow rate up to the point midway through operating range. When the decline as low flow rate rises, the pump performance data such as usually applied manufacture before pump selection, pump efficiency tend to decline over time due to wear. One important part of the system design involves matching the pipeline head loss flow characteristic with the appropriate pump which operated close or point of maximum efficiency. They are free tools that help calculate the needed pump curve including the best efficiency point. The pump efficiency is the important aspect of the pump should regular tested. Thermodynamic pump testing is one of the methods. Okay guys, this is up to straight pump operation. I hope you gained sufficient knowledge watching my video on pump operations. Thank you very much. Do take good care of yourself.